Hello, I'm Kevin Modlin, and I'm an employee owner here at InSource. In this video, I'm going to take a few minutes to show you a day in the life of an InSource OEE solution customer. But first, let's cover some quick background topics. For many manufacturers, downtime is a negative contributor to the ability to accurately plan and forecast. This frequently triggers the need to collect downtime information so that root causes can be attacked. The typical journey to collect this often starts with a clipboard and paper form. There's nothing wrong with this. In fact, it's usually a very good first step. But we often find that manual collection is not accurate or reliable enough to facilitate detailed analysis. Many plants already have field I/O that can be used to derive machine state automatically. Even if your plant doesn't have this, simple sensors like photo eyes, even without PLCs, can often provide enough granularity to get started. So adding an automated tool is often not a complex task, and it can dramatically improve the quality of the data you're collecting. If we accept that automated downtime tracking is important, what additional benefit can be gained by tracking OEE? Well, in addition to knowing when the machine is down, you'd probably also like to know if you're making saleable product at your target rate. This is where OEE, or overall equipment effectiveness, is useful as a metric. Remember that OEE is the combination of three components: availability, i.e. is the machine running when I expect it to; performance, when the machine is running, is it producing at its theoretical max rate; and then quality, what percentage of the produced items meet the expected quality requirements. Okay, that's enough theory. Let's see some of these tools in action. This is an example of what an overview dashboard might look like as a part of your HMI. Let's go through each part individually. The header shows the current production order number, the item being produced, and when that work order started. Just below that are 4 dials representing OEE and the 3 components. Notice that these are color sensitive based on whether we're above the target, well below the target, or somewhere near the target. To the right of those is a progress bar showing how far we are along in the production of this order. We're currently at 132 of 940 units. The main part of the screen is a chronology of events for the last 8 hours. I've got this filtered for the last 8 hours, but we could filter it for the current shift or 24 hours or many other types of filters. Notice that these events are color coded, so running events are in green, down events are in red, and for us, changeover events are in orange. By the way, these colors are all configurable by you. We often refer to this as a downtime tracking system, but it'd be more appropriate to think of it as an event tracking system. So changeover, you might or might not categorize that as downtime, but it's probably an important thing for you to track so that you can optimize your changeover process over time and see if you're improving that or not. Let's reset the filters so we get a smaller list of things. So let's go to only downtime events. So that'll filter this grid and only show us events that are down. And then let's further filter it to only show events that have not yet been acknowledged. So these 2 unknown events are events where the information available from the field I/O isn't enough to categorize these definitively or assign a root cause. So I'm going to use the Edit Reason button to apply a root cause to this unknown event. So let's see, there was a handling malfunction, and I can add a comment here. Okay, so now that that's been responded to, that does not show because we've got this filtered for unacknowledged events. So it might be wise to leave this grid filtered in this way so that the operator knows the things that still need a response. But if we turn that filter back off, we'll see, well, if we put that back to both. So here's the event that was recategorized to handling malfunction and the comments that I made. By the way, the original reason is always stored in the database, so even if we edit an event like this one that had a reasonable root cause, both the most current reason that's assigned and the original reason that precipitated the event are both stored in the database. two more important things to show you on this screen. So there's a function in the grid that allows me to split a single event into two, so that might be useful if, for instance, the machine went down but you took the opportunity to do preventative maintenance while the machine was down and that extended the event. Well, the software would see that as a single event, but that would actually represent two events, so the function exists here to allow you to split that single event into two and assign it to two different root causes. In the interest of time, I'm not going to go through the details of that. The production that we make is assumed to be good quality because we don't know in real time whether it is or is not. So you can see for OEE purposes our quality is currently pegged at 100%. This web application, it's embedded in the HMI, but it's a web application, allows me to manually recategorize if previously produced items as no longer good quality. So for instance, if I had 6 bad bottles, so this will allow me to update the system to know that those products were not good quality. That's going to affect the quality indication that we see in this dial in just a minute. So that's an example of a post-production quality change that affects OEE. Embedding the downtime information directly in the HMI likely means that those screens will only be available at select locations on the shop floor. As you might expect, all the functionality you've just seen is also available via web browser. This allows the solution to be tailored to meet your needs, providing the right data to the right person at the right time and location. As you've probably already experienced, the implementation of technology doesn't, by itself, solve complex problems. Most often, we need people to take action in order to see improvements. The simple illustration I like is Fitbit. Buying the Fitbit doesn't cause your fitness level to improve. Strapping the Fitbit to your arm doesn't cause your fitness level to improve. You only see results if you take action based on what the technology is telling you. Unfortunately, Downtime and OEE tools are exactly the same. The good news is that our experience with the implementation and adoption of technology in the manufacturing setting can help. Our approach is to build an interface that allows your key decision makers to get to often access reports with just a few clicks. A simple example is that we group pre-filtered reports into buckets based on how the data will be slipstreamed into your routines. Daily reports will likely need to be rolled up in one way, while weekly and monthly reports need information rolled up in a different way. Let's look at how this manifests for a Downtime and OEE solution. This is an example of a productivity detail report that you might use for a daily meeting. So the top of this report is going to show the trend of OEE over time. So this is an hour by hour trend. Just below that is the efficiency loss section. This is a bit of a waterfall. So the system was scheduled for 24 hours for the 1 day period we're looking at. We lost 5 hours and 14 minutes due to downtime. That's what this lighter green color tells me. And we lost the equivalent of almost 2 hours of production time because of performance losses, because the machine was running, but it was running at a rate lower than it's theoretically capable of. And then again, we have a Pareto availability loss type. So this might be a kind of a report you would either bring up in the daily meeting or print out and take to the daily meeting. Now let's look at a report that might be useful as an ad hoc analysis tool. I mentioned before that we sometimes view downtime tracking as the primary purpose of tools like these. It's more accurate to think of these systems as event tracking tools. I used the example of a changeover event. This report is the changeover summary, which shows us for the time period we're looking at, which is just 1 day here, what our average changeover time has been versus the target. So we're doing pretty good for this 1 day period. We're at an average of 8 versus a target of 10. Obviously we could spread out the time frame and look at a longer time frame, but this is just one example of how we might use a tool like this for something that might not be obvious at first. Well, there are many other reports we could look at, but I just wanted to give you a quick glimpse, and in the interest of time, I'm going to stop here. As you implement technologies to improve your operations, think about how to structure the outputs so that they mesh with your management routines. More importantly, think about setting triggers in advance that you'll use to generate action items for continuous improvement, and how you'll track and manage those as well. Some folks choose to leverage a software tool to help with that, and here's one of the ones we like for its simplicity. That's all for today. Thanks very much for hanging in with me. If you've got questions or would like to talk to us more about Downtime and OEE solutions, contact us using one of these methods. Thanks!